Hi everyone, in this video I will be discussing about radicals. Now radicals are numbers in the form the nth root of a, or that can be written as a to the power of 1 over n. Take note that n should be a positive integer greater than 1 and a should be a real number. Now n is called our index and a, that is called our radicand. Now this symbol, usually called the square root symbol, that is called the radical or the radical symbol. Now the left side, that is, or this is what we call as the radical form, and this side right here is called the exponential form. I think you're already familiar with this one since last time, if you can still remember, we have already discussed about rational exponents. So this one right here is a rational exponent, and if you would transform that one, you will have the radical form. Okay. By the way, if for example we have this one, the square root of x. Take note, earlier I've mentioned that n, or the index, is a positive integer greater than 1. So for radicals, the least index should be 2. We do not have an index of 1 or any number lower than 2. So if the index is 2, so just like that, we read that one as the square root of 2. We usually drop the 2. We need not write the 2 since it's already understood that if we have the square root symbol, it's understood that n, or the index, is 2. Okay? Let's have some examples. The instruction is transform the following into exponential form. So all of the 3 examples are of course in radical form. Now how do we transform radical form into exponential form? If you can still remember from our last discussion, all you have to do is copy the radicand, that's the number inside the radical symbol, which is 16. And 16 is understood to have an exponent of 1. So 1 will be the numerator and the denominator will be the index, which is 4. So 16 to the power of 1/4, this is the exponential form of the 4th root of 16. Second one, we have the 10th root of 8x. So for this, we need to enclose 8x in a parenthesis. Why? Say for example, we have 2x cubed. If we have this example, that means only x is raised to the exponent 3, but not 2. So we need to enclose both terms, or the numerical coefficient and the variable, inside the quantity, so that both of these will be raised to our exponent. So it is understood that the exponent is 1. Then again, for the denominator, it should be the index, which is 10. Okay? Number 3, we have the quantity, or the square root of x squared plus y squared. Again, so that we will ensure that both of the terms will be raised to the exponent, we need to enclose it in a parenthesis. So that's the quantity of x squared plus y squared, y squared, then our exponent is 1/2. Why? It is understood that the exponent numerator is 1, then the radical or the index of the radical is 2. So that's it for transforming radical form into exponential form. Now, let's try to evaluate the following radicals. Number 1, that's the square root of 16. So, how do we evaluate? So, number 1 actually is very easy. All you need to do is think of a number, a certain number that you have to multiply by itself twice, then that will result to the radical 16. So, of course, the answer for number 1, the square root of 16, is simply 4. Why? If you square 4 or multiply 4 by itself, which is 4 times 4, that will result to 16. Therefore, the square root of 16 is simply 4. Okay? Number 2, the cube root of negative 125. So, same with number 1. Think of a certain number that you can multiply by itself 3 times will result to the radicand negative 125. You can actually pause the video. You can think in order to get the answer. You can also use your calculators if you want. If you want to get the answer right away. But if you would like to have a challenge, then you can try it manually. Anyway, for number 2, the answer there is negative 5. Why? If you raise negative 5 to 3, that's negative 5 times negative 5. I'm sorry. Negative 5 times negative 5 times negative 5. Negative 5 times negative 5, that's positive 25 times negative 5, that gives us negative 125. Therefore, the cube root of negative 125 is simply 5. Number 3, we have the fifth root of 243. So, same with the previous examples, think of a certain number that you can multiply by itself 5 times in order to get 243. So, for number 3, our answer is simply 3. Why? If you raise 3 to 5 or multiply 3 by itself 5 times, that's 3 times 3, that's 9, times 3, 27, times 3, that's 81, times 3, that will give you 243. Therefore, the fifth root of 243 is simply 3. Number 4, that's the fourth root of 1296. So, think of a certain number that you can multiply by itself 4 times will result to the radicand 1296. If you thought of 6, yes, you're correct. Because 6 times 6 is 36. Times 6, that's 196. Times 6, that will give you 1296. Therefore, the fourth root is 1200. I'm sorry, the fourth root of 1296 is 6. At this point, let's talk about properties of radicals. Number 1, the nth root of a to the power of n is equal to a. Why? If you transform this one into exponential form, so the nth root of a to the power of n, so copy the radicand, the numerator is the exponent, the denominator is the index. So, if you simplify n over n, that would be equal to 1. And in mathematics, we need not write 1 since it's understood that there is only one a. So, that's the reason why if the exponent and the index are the same, the simplified answer will only be the radicand. Number 2, we have the nth root of AB is equal to the nth root of A times the nth root of B. So what happened in number 2 is simply distributing the radical symbol since A and B are a product. So you can distribute the radical symbols to A and also to B. Number 3, we have the nth root of A over B, that is equal to the nth root of A over the nth root of B. So number 2 is a product, number 3 is a quotient. And the same rule applies that you can distribute the radical symbol to a certain quotient. So we can find the root of the numerator and the denominator separately. So these are the basic properties for radicals. But take note, we can only break up the radical symbol or distribute the radical symbols if it's for products and quotient, but not for sums and differences. So if we have, let's say, the square root of A plus B, we cannot do this. Square root of A plus square root of B. Also, if we have A minus B, we can't also do this one. This is a big no because the properties only apply for products and quotients. Again, not for sums and differences. Okay? Let's now proceed to simplifying radicals. So, in simplifying radicals, we need to follow these certain rules so that we can make sure that our final answer is already in its simplified form. Rule number 1, all exponents in the radicand must be less than the index. So we need to make sure that whatever exponent is inside the radical symbol, it should always be lesser than the index in order for us to determine that the answer is already in the simplest form. Number 2, any exponents in the radicand can have no factors in common with the index. Let me give an example for number 1. So let's say we have the square root of x cubed. So this is not, x cubed. This is not yet in the simplified form. Why? It says in the rule, exponents in the radicand must not all exponents in the radicand must be less than the index. The index here is 2, and the exponent inside the radical symbol is 3, which is not yet in the simplified form since we can still look for a way to simplify this one. But if we have x there, the square root of x, this is already in simplified form. Why? The exponent is 1, the index is 2. So the exponent here is already less than the index, therefore this is in simplified form. Number 2 says exponents in the radicand can have no factors in common with the index. So let's say still we have the square root of x to the 4th. So the index is 2, the exponent is 4. So there are still, it can still be factored out, this can still be simplified. Therefore, this is not yet in simplified form. But if we have, let's say, cube root of x squared, so this answer is already in simplified form. Why? The exponent, which is 2, and the index 3 doesn't have any common factors. We cannot divide 3 by 2. We do not have any more certain common factors. Number 3, no fractions appear under a radical y. Based on the rule earlier that we can distribute the radical symbol for quotient. So if there are still fractions, we still need to simplify that one. Number 4, no radical appears in the denominator of a fraction. So in simplifying radicals, make sure that the denominator is not a radical. The numerator can be a radical but never the denominator. Now we have examples for simplifying radicals. Number 1, we have there the square root of y to the power of 7. So how do we simplify this given radical? If you can still recall the laws of exponents, y to the power of 7 can be rewritten as y to the power of 6 times y. You may ask why. Because if you can still recall laws of exponents, if we have the same base, different exponents, and there is an invisible one here, so we can actually add 6 and 1, that gives us 7. Why did I do this? In order to simplify, in order to extract whatever that can be extracted outside, to the outside of the radical symbol. So y to the power of 6, we can look for the square root of that one. So if you transform that one into exponential form, that will be y to the power of 6 over 2, because y to the power of 6 over 2, because the exponent is 6, that's the numerator, the index is 2, so that's the denominator. So if you look for the square root of y to the 6th, that will simply be y cubed times y. So the remaining y cannot be simplified anymore since its exponent is 1, right? And if you transform that one into exponential form, that's y to the power of 1/2. And also, the exponent now is lesser than the index, so 1 is lesser than 2. Therefore, this is already in simplified form. Number 2, we have the 9th root of x to the power of 6. For number 2, we can actually transform this one into exponential form. We can rewrite that one as x to the power of 6 over 9. And we know that 6 over 9 can still be simplified. We can look for a certain common factor that we can divide to both numbers, which is 3. So if we divide both numbers by 3, the numerator will become 2, the denominator will become 3. So that's x to the power of 2/3. If we transform that one back into radical form, that will be the cube root of x squared. This is already in simplified form. Why? The exponent now is less than the index. 2 is less than 3. Therefore, this is already in simplified form. Number 3. Suppose we have the square root of 18 x to the power of 6, y to the power of 11. How do we simplify this one? We can look for factors that has certain roots or square roots. So, for 9 can be factored out as 9 times 2. Why? 9 times 2 is 18. And 9 can be put outside of the radical symbol later because 9 has a square root. Next, x to the power of 6, we can simplify that one later. Y to the power of 11, we can simplify that, or we can rewrite that one as y to the power of 10 times y. Because, again, rules of exponents, same base, different exponents, that's 10 plus 1, that gives us 11. And the reason that I chose 10, because 10 can be divided by the index 2. So therefore, we simplify that one. Square root of 9 is 3, right? Square root of x to the 6th power, or x to the 6th over 2, that is x cubed. Then, if we have y to the power of 10, that's simply y fifth, because 10 divided by 2, the index is 5. And what will remain in the radical symbol are 2 and y. This is already in simplified form since 2 doesn't have a square root, and the exponent of y is already lesser than the index. Let's have example number 4. Let's have the fifth root of x to the power of 12, y to the power of 4, z to the power of 24. So how will we simplify this one? Take note of the index, which is 5. So as for the exponents, we need to factor out this one so that the exponents can be divided by the index. So x to the power of 12, we can simplify as x to the power of 10 times x squared. Because again, 10 plus 2, that's 12. 10 can be divided by the index 5 later. Y to the power of 4. Wait, let me just move the answer here. So again, the fifth root of x to the power of 10, x to the power of 2, y to the fourth, that's already in the simplified form because the exponent is lesser than the index. So simply copy y to the fourth. Then z to the power of 24, we can rewrite or simplify as z to the power of 20 times z to the power of 4. Why did I choose 20? Because again, our goal is to find exponents that can be divided by our index. Wait. Now let's simplify or find the roots. So x to the power of 10, if we look for the fifth root, divide 10, the exponent 10 by the index 5, that will result to x squared. So this one is already simplified. Same for this one. Z to the power of 20 can be simplified as z to the power of 4, because 20 divided by the index 5 is 4, and what will remain inside the radical symbol are x squared, y to the fourth, z to the power of 4, the fifth root. So this is already in simplified form because the exponents are all less than the index. If you have questions, kindly type your questions in the comment box below, or you can also ask in our group chat so that I will be able to answer your queries. Okay? Now let's talk about multiplying radicals. So in multiplying radicals, it's somehow the same with multiplying polynomials. So for number 1, we can actually apply the FOIL method. If you can still remember, FOIL stands for first, outer, inner, last. So if we multiply the first terms, that's the square root of x times the square root of x, that is equal to the square root of x squared, right? Then outer, that's negative 5 square root of x. Inner, that's positive 2 square root of x. Then last, that is negative 10. The square root of x squared can be simplified into simply x. The middle terms can be added because they are similar terms. They have the same variable, square root of x. So what we do is simply add or subtract the coefficients. Negative 5 plus 2, that's negative 3. Simply copy the variable, square root of x, minus 10. So that is now the product of the two radicals. Number 2, let's have 3 square root of x minus square root of y times 2 square root of x minus 5 square root of y. So same with number 1, we can still apply the FOIL method, multiply the first terms. Now this time, there are already coefficients before the radical symbol. So we can multiply the coefficients 3 and 2, that's 6 square root of x squared. So we can multiply the variables inside the radical symbol x and x, that's x squared. Then outer, that is negative 15 square root of x square root of y. So we cannot combine since these are two different variables. Just simply copy. Inner, that's negative 2 square root of x square root of y. By the way, always write letters or variables in alphabetical order. So x first before y. Then for the last, that's negative and negative, that's positive 5 square root of y squared. Y times y is y squared. Simplifying, square root of x squared is x, so that's 6x. The middle terms can be combined since again these are similar terms. They have the same variables, square root of x, square root of y. So negative 15 minus 2, that's negative 17 square root of x square root of y plus 5, then square root of y squared is simply y. So that's the final answer. By the way, before we proceed to example number 3, if you would recall earlier the rules for radicals, square root of x, square root of y, we can actually combine. We can put those variables inside the same radical symbol. So I'm sorry, this is by the way our final answer. Okay. Example number 3. If you can still recall the factoring, special products, we can actually apply the sum and difference of two terms. Why? We have the same first terms, the same second terms. The only difference is that the signs are different. But let me show you the answer using the FOIL method first. So using the FOIL method, first, that's 25 square root of x squared. Outer, that's negative 10 square root of x. Inner, that's positive 10 square root of x. Then last, that's negative 4. If we simplify that one, that's 25 square root of x squared is x. Negative 10 plus 10, that is 0 minus 4. Therefore, this is our final answer. So, if you have the sum and difference, but the terms are the same, you can actually square the first term, then simply square the second term, but the sign is negative. Our last topic for this lesson is rationalizing radicals. So earlier for the rules in simplifying radical, the fourth rule states that no radicals appear in the denominator of a fraction. So we have here a fraction, and there is a radical symbol in the denominator, meaning this is not yet in simplified form. So we simplify this one by rationalizing. Now, how do we rationalize? We need to multiply the whole fraction by the given denominator, square root of x over square root of x, in order for us to remove the radical symbol in the denominator. Now we do this because square root of x over square root of x, that's still equal to 1. Okay, so multiplying numerator to numerator, that's 4 square root of x. For the denominator, that's square root of x squared. So we have 4 square root of x over x. So this is already now in simplified form because even if there is a radical in the numerator, there is no more radical in the denominator. Number 2, let's have 1 over 3 minus square root of x. Earlier, in order for us to remove the radical symbol, we just simply multiply the fraction by the denominator. Now in this case, this is different since we have a difference. So in order to remove the radical symbol on the denominator, we need to multiply the whole expression by the conjugate of the denominator. So what do you mean by conjugate? To simply copy the expression, but the sign should be the opposite. So if it's positive, then it should be negative. So it will look like this: 1 over 3 square root of x times 3 plus square root of x over 3 plus square root of x. So multiplying 1, that's 3 plus square root of x. Then if you can remember earlier for multiplication, since these are the sum and difference of two terms, same first term, same second term, but the signs are different. So simply square the first term, square the second term, sign should be negative. So 3 squared is 9. Then square root of x squared, that's simply x, but the sign is negative. So square root of x squared, right, is simply x. Therefore, this is now our final answer, since there are no more radical symbols in our denominator. It doesn't matter if there is a radical symbol in our numerator. And lastly, let's have example number 3. So we have 5 over 4 square root of x plus square root of 3. So here, let's multiply again by the conjugate. So that's 4 square root of x minus square root of 3 over 4 square root of x minus square root of 3. So multiplying, that will give us 20 square root of x, then negative 5 square root of 3. So still the sum and difference of two terms, so simply square. That's 4 times 4, 16. Square root of x squared is simply x, minus square root of 3 squared is simply 3. We can actually simplify the numerator since we have a common factor. So we can bring out 5. So that's 5 times 4 square root of, 4 square root of x minus square root of 3 over 16x minus 3. So what I did was only to bring out the common factor, since 20 and 5 can be divided by 5. So that's it for our discussion. Again, for any questions, you can type it in the comment section below, or you can send it in our group chat. Thank you so much for your time. You take care always. Bye-bye for now.